Welcome to DevVenture with MTK. This is the 56th episode in our Space Shooter DevVenture. And at the end of our last session, we had just about started the design of the next phase in our flea behavior and the NPC behavior manager in general, right? So we had this idea where if the AI actor is doing a behavior or following a behavior pattern, and suddenly an emergency behavior or operation needs to take place, right? So for example, an attack pattern is underway and the enemy AI has to do an emergency flee maneuver because they are on a collision course towards an asteroid or something that they can't destroy, right? And it's not the intended target also. So there are these criteria that are met. And in that situation, we want the AI actor to dodge or flee, right? But we don't want to lose the current pattern. And so the idea is we want to save the pattern or put it on pause, perform this emergency behavior or operation, and then resume the pattern again where we left off, if possible, right? Again, if possible. So if after performing the flee operation, the target was lost, or there's no longer line of sight or something, right? Then of course the behavior is going to fail, the pattern's going to fail, and everything's going to fall apart. But what we want to try and do is give the AI actor a fighting chance to complete the behavior successfully and not fail it, right? So we had these discussions with Perplexity about how we'll be able to handle this, right? And we also had these concerns like, okay, well, what happens if while performing a flee, it needs to do another flee, right? Like what happens if it gets stuck in a so-called asteroid belt or whatever, and it's really densely populated with these collision objects that can't be destroyed by gunfire? How is it going to dodge each of them? And so we came up with a solution that is, we simply keep overriding the existing flee operation with a new one without resuming or pausing or perpetuating that pause, resume cycle with our existing behavior, right? We keep the paused behavior paused, and we just keep overriding the intermittent or the emergency behavior instead. And so it'll be like flee, and then flee again, and then flee again, and then flee again, and then flee again, until there's no more need to flee. And at that time, we resume the current operation, and if possible, and everything will carry on as it should, right? And this works around the problem of adding to a stack, because if you have a stack and you keep pausing and pushing back onto the stack every time, the problem with that is you've got a limitation, right? You've got a memory limitation, and then there are only so many times you can pause because you will run out of memory, right? And the user's machine can only hold so many items on the stack, and you don't know how many items they can hold on the stack because their machine is different to basically everybody else's. And now you're sitting with a problem. And so as a result of that, we need a solution that doesn't take up memory, right? So we don't use a stack. We just discard the current emergency behavior and take on the next one in place of it, while keeping the paused operation or the paused pattern intact. Right? So I hope that's clear. I've taken quite a bit of time to explain it again, but I think 5 minutes at the start of each live stream as a recap is a small price to pay for context and continuation, right? So by the end of it, we kind of asked some questions, and Perplexity asked them how repeated overrides still resume correctly. So I kind of covered all of this. right? Now let's go into the actual development. Okay, so let's begin with that. So I can so I'm going to slow down a little bit. I noticed that my my talking speed and my thought processing are clashing, and that leads to a kind of stutter. So I'm going to slow down my speech and take my time, and hopefully that clears things up, because I don't want to be unclear in my communication, right? I want you to be able to follow along with what I'm doing, and I want you to be able to understand what I'm saying. And in order for that to happen, I need to just be more deliberate with my speech. So I'm going to type a message into Perplexity now and basically say, I'm happy with what we've decided on. Let's go ahead and create the code. Okay, so I'm going to type that out, and I've already explained what I'm going to say, so you don't have to like follow along as I type it. You know what I'm going to tell it, right? So let's just go ahead and say it, right? Okay, so this is what I wrote. Okay, I'm happy with what we've come up with. Thanks for clarifying and modifying the approach to address my concerns. Let's go ahead and create the code now. I think it will be best if we deployed it in phases like we did with Flea at the start. Are there still phases left in the Flea behavior that we should remember to revisit at the end of the process? If so, please keep them in mind. Okay, so let's see what it says. Alright, so there are still a couple of Flea refinements worth revisiting later, but they do not block implementing the override or resume system now. The refinements to remember for later are better obstacle choice or multi-obstacle handling. Right now, Flea uses a single cache deflection direction. Later, you may want a couple of raycasts along candidate directions to pick a so-called clearer escape heading, and an optional max duration or max distance failsafe with a Flea timeout for failure reasoning. And danger versus safety radius tuning. Current values are reasonable defaults, but final tuning should consider the ship's speed and the turn rate, and typical obstacle types. My apologies. Typical obstacle sizes and densities in your level. Right. So how close together are the obstacles, and how big are they? How small are the gaps between them? You know. And then these can all be done after the override lane exists. Of course, that makes sense, right? So you want the safety radius, or rather the danger radius, to be larger than the external surface of whatever collision object you're talking about. And that makes sense, right? Because the danger radius starts from the center of the object, which is typically at the center of the 3D model as well, right? The origin of the game object. And if our danger radius is too small, then it might come within the collision object, right? So if the asteroid is quite big and the danger radius is too small, it might fit inside the asteroid, and then our AI actor will end up smashing into the asteroid long before it reaches the danger radius, and that's not what we want. And so we're going to need to have some kind of sophistication in our code to determine what I might call a flexible radius, right? Where the radius has this offset from the collision surface of the collision object rather than the offset from the origin of the object. I'm not sure exactly how we'll do that just yet, but it's something to consider, right? And we might have to do some kind of like get maximum extent in terms of the collision object, and then apply the offset to the maximum extent rather than the minimum extent, and all that kind of complicated or seemingly complicated. It's not actually complicated, but it seems complicated right now because I'm speaking without showing diagrams, right? Anyway, that's all a digression. These are all refinements for Flea. We're not talking about Flea now, are we? We're talking about the interruption system. Pause and resume. Then there's the these can all be done after the override lane exists. So the next coding phase is to add a behavior override lane in the NPC behavior manager. So we save the current pattern or behavior state, pattern and behavior, right? So the current pattern, we save it, and the current behavior, we save that too. Because remember, the pattern is just an entry in a dictionary that has an array of behaviors, and the current behavior is literally just an index in that array, right? So it's like index 5 out of however many. So we save the pattern, which is attack, we save the index, which is whichever, 0, 1, or 2, and then that would be saving it, and then run the Flea operation or the whatever overrided operation, and then we restore or resume the saved pattern afterwards. Once that is in and tested, then we can wire it to the real danger detection and later circle back to the Flea refinements. Okay. So now I'm going to reply and I'm going to say something like, let's go ahead and write the code now. You know? So something like, oh, it's already done the phase? Okay, so let's go ahead and start phase 1 now. Sounds good. Let's go ahead and start phase 1 now. Excuse me. So follow the same pattern as we've done before, where you explain where the code should go. Where you write the code and explain where it should go. Again, like I said before, I have no problem with letting the AI write the code for me, as long as I audit it at the end and I explain the logic or the algorithm of the code myself, right? So I tell Perplexity what the code should do, or I have a say in what the code should do at a very explicit and clear way, right? From a high level perspective, I explain the code needs to do these things and it should accommodate these cases that might break things, whatever and whatever, right? And then Perplexity can go ahead and think about the low level implementations and write the actual code. And then I audit the code at the end. And so I'm not uninvolved. I'm not oblivious to any mistakes that it makes. And I can catch those mistakes because I'm auditing the code at the end. But I've talked about this enough. This is just one of my pet peeves, is that people like to generalize and say AI should never be used for writing code. That's not entirely true. And you've seen that, right? You've seen the success rate that I've had with using Perplexity to create the code in my engine of choice, that is Godot engine, and in my project, that is Project-AstroMiner. You've seen that there's a success that has been continuing, and the so-called threats of technical debt have not accumulated. In fact, they haven't been seen, and I've been able to make more progress than before. When I was writing the code myself, I've been able to make more advancements and make more complex code, more sophisticated features, and I'm able to just move forward with my project. And I'm actually interested in continuing, and it builds my motivation and it boosts my morale rather than reduces motivation and destroys my morale every time I make mistakes, or I don't know what to do, or I can't figure out how to write the code for myself. And I need to go and look at documentation, and it takes up all this additional effort and cognitive load. And you see what I'm getting at, right? It's a tool. If you know how to use the tool, it can't possibly be a disadvantage. But if you don't know how to use the tool, then of course it's going to be dangerous and a disadvantage to your workflow. So enough. Let's just carry on. We can talk about this maybe on Discord. So maybe that's a good time for me to mention the Discord server, right? Join the community, DevVenture with MTK on Discord. It's down in the description of this video. The link is there. You can join. It's open to you and anyone else. And the link should be available. I made it so that it doesn't expire. If you click the link, you should join the server, and I welcome you in advance. Right? And then also go ahead and check out coffee.com/mtkdev to support this channel. And thank you so much to Cubes. He is our junior DevVenturer. That's the middle membership tier on the Coffee page. You can go ahead and look at those membership tiers. The perks are listed on that Coffee page. And on the Discord server as well, there are all restricted categories of channels exclusive to Coffee members, right? As I call them, DevVenturers. You've got interns, juniors, and seniors. And, it's all there. Go ahead and check it out. Now, back to what we were working on, right? So follow the same pattern as we've done before, where you explain the code, where you write the code and explain where it should go. So phase 1 will add a simple override lane to the NPC behavior manager and a method to trigger flee as a temporary override, without yet wiring any collision logic. This will let you test override/resume manually later. So below are only the minimal changes you need to make. Extend the NPC behavior manager state in NPC behavior manager.gd near the other state variables. Add these new fields and place them below shared parameters for clarity. Right? And then add a start override behavior helper. That's a helper function, in case that wasn't clear. Still in the NPC behavior manager, you add this function, for example, just below discover behaviors. And then that's the code for it. And then there's some notes. Phase 1, if in override is already true, new override requests are ignored and then later you can add logic to update the existing fleas parameters instead. Okay, and then 3, update on behavior completed to handle override flea. So in MPC behavior manager.gd, we modify the on behavior completed function so it can detect when an override flea finishes, restore previous states, and not treat it as pattern completion or failure, which is important, right? So we replace the existing on behavior completed logic with this version. The addition, or the main addition, is the override handling block at the top. Okay. Key points: when an override flea completes, in override is set to false, current behavior is cleared. If saved pattern is not empty, the manager restores current pattern and sequence index, and then calls start next behavior to continue the pattern. Then the saved state is cleared, and for non-override behaviors, the existing logic remains unchanged. Excuse me. And then phase 1 testing, which is optional but recommended. For now, do not wire this to collisions. To sanity check, you can temporarily call start override behavior from somewhere safe. Example, a debug input in NPC behavior manager or enemy ship controller while an attack pattern is running, and then pass a danger position near the ship so flea actually moves it. And then when flea completes, we watch the logs. Example, debug hook. And then you can call debug start flea override from a key press in input or from the console to verify override resume behavior works before adding real obstacle detection. Okay, so that seems all straightforward and reasonable. Is 4 steps to phase 1. And then we'll move on to phase whatever, 2, 3, 4, however many phases it takes to make this work. Right? But again, there's this rudimentary stage, which is literally just the groundwork and adding an emergency manual override key on the keyboard that makes me force an emergency flee operation or something, right? That it's like, oh, I need to flee from this particular location. And then it does that, and then it resumes. It resumes the current pattern that it was doing, that it paused before, right? So it pauses the pattern, does the operation, and resumes the pattern. So what I'll do now is I'm going to go back up to phase 1, and I'm going to take this to the side like I always do, and start implementing in the script, right? So in the script editor, we'll go towards the NPC behavior manager, jump up to the top here at the top of the script, and below shared parameters. So there's shared parameters. We need to place that below shared parameters. So let's go ahead and do that. We add these variables. All right. So what I'm going to do now, I'll copy this block of code and just paste it in, all neat and tidy. And then we just have to do that and this. Okay, so that's the step all done. And then step 2 is to add a start override behavior helper function, which I will add right at the very bottom here, right? So 3 lines and then function. I'll just copy the code. Because it's a brand new function, I don't have to write it myself, right? But I will audit the code. So function start override behavior takes in behavior name, which is a string, and then override parameters, which is a dictionary, and returns void. All right. If already in an override, then ignore new requests. Phase 1 takes in only one override at a time. So if in override, then we print this message, NPC behavior manager override request ignored, we are already in override, and then call return, right? So we cut out of the function early because there's no need to do any of this. We are already in override. If we are not in override, then we jump past this if statement and we create this variable, right? We just make a new line there to separate this from the if statement. Variable key called behavior name dot to lower. So we take behavior name, we bring it down to lowercase, assign it to this new variable called key, right? And behavior name, remember, is a string up here. Then if not available behaviors dot has this key. So if the available behaviors dictionary does not have key, then there's an error, right? Because this behavior doesn't exist. So we'll then say NPC behavior manager override behavior not available plus key. So the key is not available in NPC behavior manager, and we push that as an error, call return. Again, we cut out of start override behavior. If that doesn't work, so if it is actually in available behaviors, so if available behaviors does have the key, we continue, right? So now we save the state of the pattern and the behavior. So in override is set to true. So the next time this is called, in override will be true, and we'll just cut out, right? So in override is set to true. The saved pattern is set to be the current pattern. Again, current pattern is defined somewhere up here. Yeah, there it is, right at the very top. See, current pattern of type string. So the current pattern is saved as the save pattern, and then saved sequence index is the sequence index. We save that, and the saved behavior is the current behavior. Okay, and let's not forget that these should all be collimated. Bring them up to line 60, which is correct, right? And then this one goes to line 62, 60 as well, not 62, as in 61 plus 1. So we finished through there. Then we print a message to say that the NPC behavior manager is starting override behavior, the key, and then we're starting this behavior for the ship with the ship ID, right? For ship whatever number that ship is. Activate override behavior without touching current pattern or current sequence. So the current behavior is available behaviors at key, and we assign that to the current behavior. If current behavior and current behavior has method activate, so if current behavior is not null and it has a method called activate, then we call the activate function for current behavior, passing in enemy ship ID and any override parameters that might be there, right? And we are done. So that's the end of step 2. Now we do step 3. Just making sure all my alignment and formatting is done. Seems like it is. Perfect. So step 3, we need to update on behavior completed, which is just above that, which is this thing. We need to update it so that it can handle override flee. All right. So in NPC behavior manager.gd, we modify on behavior completed so it can detect when an override flee finishes and restore the previous state so that it does not treat the pattern completion as a failure or as a completion. So the pattern isn't marked as done or failed, it's just paused, right? So there's 3 states that a pattern can be in, right? Well, 4 is either the pattern's in progress, it's paused, it's completed, or it's failed. Those are the 4 states that a pattern can take on. So I'm just going to go through the code that Perplexity has written here on the side and modify the code here to correspond with it. So if enemy ship ID is not equal to enemy ship.id, then return, that's fine. The print statement is fine. Here's the override code. So we add it in before the match block. Wow, that's a lot of code. You know what? I'm just going to... No, but if I copy and paste it over, then I don't learn anything about the additional changes, right? So I'm not going to do it that way. I'm going to go through it manually and see what happens, right? So we're going to create the comment to say that the override lane handling phase 1 only flee as the override. So here's the code. If in override and behavior type is flee, then we need to print the following message. NPC behavior manager override behavior flee completed with status and then status. Okay, and then we set in override to be false. We just shift this over to line 60. Okay, and then current behavior is also set to null. And then hash if there was a saved pattern, then restore basic state. So then if saved state, or rather saved pattern, was not an empty string, then current position, or rather current pattern, is set to be saved pattern. We just shift this over to column 60 again, and sequence index can be set to be saved sequence index, and here we say do not clear current sequence, as it still holds the pattern steps. Right, so now we need to print a message that says the following piece of code: NPC behavior manager restoring pattern, current pattern at sequence, sequence index. Right, and then here we need to add in the following. After restore, you can choose A, to reactivate the saved behavior, or let the pattern advance to the next step. For phase 1, we will simply continue the pattern from the current sequence index. So we'll call start new behavior. Start the next behavior. And then there's an else statement here. We print this message. And at the end, we call clear saved state. which is saved pattern set to an empty string, then saved sequence index set to 0, and saved behavior is null. And then we call start next behavior. Oh, hang on. There's some more to come in between this. So after that, we need to have a signal ready, which is optional, but keeps contract. And so we should probably just do that. We need to say ready for pattern dot emit enemy ship ID. Then we print a statement taking in this message here, and we call return. So we are in the in override then. Okay, so we call return, and that would be the end of this. End of end override lane handling. Okay, then we go back to normal pattern. So this is normal pattern behavior handling. Which takes in the match status or the match statement as before, right? So match status completed, move to this next behavior, sequence incremented, set to null, call the next behavior. If failed, then we create a reason, we print this message, pattern failed at emit, current behavior is null, the pattern is empty string, sequence.clear, ready for pattern.emit, and the print statement. Perfect. Perfect, good. Just want to see something. That's fine. Okay. I just need to move these 3 assignment operators to be at column 60, and then that step is also done. Okay, so now that's fine. Save that. And now we can go into step 4 of phase 1, which is testing, right? Phase 1 testing. So in npc behavior manager.input, we don't have an input here, or a temporary method. So I'm going to go to project settings, go to the input map, add a new action. I'm going to call this interrupt manually. And then I'll add that and set a key press I. I for interrupt. Okay. Now, where was the... Okay, so before I do that, I want to just go back to Perplexity and get some clarification, right? I've finished steps 1 through 3, and I want to do step 4 next. No, edit this. Are you sure I should add the input checking to NPC behavior manager.gd? I've created a new control in the project settings menu called interrupt manually, which listens for the keyboard key I. The other debug key presses are being handled in enemy ship controller .gd. So I was wondering whether this new key should feature there as well. What do you think? Please explain your motivation for the choice you make. Handling interrupt manually in enemy ship controller.gd is the better choice for both consistency and architecture. Why enemy ship controller is the right place? It has consistent debug input, so all your other debug controls, number keys, UI accept, test attack pattern, already live in enemy ship controller.input. Keeping I there means anyone reading the code knows global AI test controls are in the controller. On the controller, instead of hunting through per ship scripts. Exactly, right? So layer responsibilities, the enemy ship controller is your strategic or coordination layer. It knows which ship to command and when to issue high-level orders. So type NPC behavior manager is tactical or operational for a single ship. It acts on commands, but should not be responsible for polling global input or deciding when to start tests. Keeping input in the controller preserves that separation. The controller decides, start a flee override for ship 0 now. And the manager just runs it. So feature scalability, or rather future scalability, if you later want to interrupt a specific ship in your squad, or interrupt all ships with a single key, then doing that in enemy ship controller is straightforward by looping over enemy ships or just picking an index. And doing it inside each manager should either require duplicate logic or extra global references, which we don't want, right? And so how do you wire it? In enemy ship controller.gd, under the input function, we add this check and run the attack pattern as before, and then press I to trigger a flee override mid-pattern and match the resume behavior. That keeps input handling centralized in the strategic controller while still exercising the new override lane in NPC Behavior Manager. So before I add this code, I just want to go through it and make sure it makes sense, you know? So if event is action pressed interrupt manually, for now, interrupt ship 0 as a test. We only have ship 0 on the scene anyway. If enemy ships dot size greater than 0, you know, so we have at least one ship on scene, then the variable we're calling ship, which is just the current ship, we set that to be enemy ships at 0. If the ship is not null, right, and the ship has a node NPC Behavior Manager, then we create a variable called manager and assign the NPC Behavior Manager of that ship to this variable as type NPC Behavior Manager, right? And then if that is not null, we create the danger position, which is the ship's global transform.origin plus ship global transform.basis.z times -20, which is just a threshold radius or whatever. And we print enemy ship controller manually starting flee override for ship ID. Then the manager starts override behavior flee. Danger position is the danger position we just created over there. It will perform a flee around that danger position, which is literally just a point in space. It's going to flee that point in space, which we create. It's literally just 20 units ahead of the enemy ship. It's going to be a fake danger spot, which we define, and it's going to flee around it. Then once that's done, it's going to obviously, hopefully, resume the attack sequence. Run the attack pattern as before, then press I to trigger a flee override in the mid pattern and watch the resume behavior. That keeps input handling centralized in the strategic controller while still exercising the new override lane in NPC Behavior Manager. So we just have to add this in, right? So we'll just copy that and then head on over to enemy ship controller.gd, go to the input function, which is this, and over here, just below that, paste it in. And then obviously we just undo that one indentation. Just going to tidy this up for a second. All assignments are on column 50. So this goes to 50, and this goes to 50, and that goes to 50 altogether, like this. And then yeah, that looks okay. We can save the code, go into testing seek behavior, and run. Let's see how it works. Okay, so we want to call the attack pattern. We'll press spacebar for that, and then as it goes, we'll press I to interrupt. Nope. Not working. it's not working. Just want to go back to project settings and make sure interrupt manually. We'll just copy this and go back to the script and make sure it's spelled correctly. Seems like it is. Project settings. It saves automatically, so it should be there. Key press I. So I'm going to add a print statement here, just to say, like an acknowledgement that the key press is actually being pressed, right? So we'll call print activated key interrupt manually. And then at the end of this, if this does not execute, we need to make another print statement here to say we'll just do that for now, right? And then run this. We'll press 4. Oh, right, 4 on the numpad. And then we'll press I. So it is activating the key press, but it's not doing what it's supposed to. Okay. This will probably be the last thing I do for our session, because we are nearing the end of the hour. We have about 8 minutes. Well, 7 minutes and like 15 seconds. So here is the code you told me to add. As you can see, I added a print statement to make sure the key press registered, because it isn't doing anything. The interruption logic is not working at all, and the AI actor continues as if the key was not pressed, or rather was never pressed in the first place. What do you think is causing this problem? What is it saying? The problem is earlier in your input chain. The if event is action pressed, interrupt manually block is never reached, so the override call into the manager is never made. From what you described, no activated key interrupt manually line in the log. No. It is showing. even though the print statement appears when I press I, the interruption logic is not working at all, and the AI actor continues as if the key was never pressed in the first place. What do you think is causing the problem? Okay, let's see what it says now, because this is now the real problem. The key press is reaching enemy ship controller, so the issue is almost certainly in one of the three places inside the override path. Either the manager is refusing the override because in override is already true, the behavior key flee is not resolving in available behaviors, or flee activates but immediately completes or fails in a way that you do not see because the pattern resume path is not wired quite as expected. So given your earlier logs, the most likely culprit is 1 or 2. So in 1, check the in override guard. In start override behavior, you have this logic. If in override was accidentally left true, every call to start override behavior will be ignored. Temporarily add a print at the very top of start override behavior, and then run the game, start an attack pattern, press I. If you see override request ignored already in override, then in override is stuck on true, and the fix is to verify that in the flee completion path, you always set in override to be false, and that you actually reach the code. And then verify key mapping. Start override behavior uses key behavior name to lower, but behavior discovery uses behavior type child name replace to lower available behaviors. Okay, so for the mapping to work, the node in the scene tree must be named behavior flee. But it must be in the behavior nodes group. Is it in the behavior nodes group? Let's just check this. Behavior flee node groups. It is. And it is called behavior flee. So that's fine. If the node name is something else, behavior type will not flee, and available behaviors will not have the flee key. So we need to check available behaviors, the available behaviors dictionary at startup, and you should already see something like this. If flee is missing there, rename the node under NPC behavior manager to this, and ensure it falls under behavior nodes in the behavior nodes group. Also add a print right after the key check. Okay, so let's do that. Let's go to the very top. We should see flee, behavior flee. And what did Perplexity say we should see? Flee, behavior flee. Yeah, exactly. Right, so it's working. That's there. Add a print right after the key check. If flee is not on that list, the override call will silently be blocked by not available behaviors .haskey. And then the third thing we can do is to confirm that flee actually runs when invoked as an override. You already know flee works as a pattern step from the attack sequence. So to confirm it runs via override, ensure activate in behaviorflee.gd prints something like this. After you press I, look for that line, and if you see manually starting flee override, then print from enemy ship controller, but do not see the flee activation print, then run start override behavior. Or rather, then start override behavior is not reaching current behavior.activate, which is blocked by in override or missing flee key. If you see flee activation print, but the ship still does nothing, then process in flee is likely returning early, and in that case try a closer danger position. You know, that's probably it. That's probably the simplest solution. If I go to flee and I go to the inspector, we see the danger radius is 10, right? And so all we have to do now is go to enemy ship controller and change this to -10. Yeah, because the safety radius is 20, so of course it's not going to flee because it's already it's already so let's make this smaller. We'll make this -8, so it's inside the danger radius and also less than the safety margin. And now it should override because, you know, we should probably add some more sophistication to this, but again, it's only a debug check, right? That's fine. Testing seek behavior. This should work, and then we can close the live stream with peace of mind that it is actually working. So I'm going to say start the attack sequence, call interrupt. Go to a random waypoint, call interrupt. Still not working. So yeah, we'll have to work through that systematically. And I'll try and do some of that now after the live stream is done. But if I don't get around to it, because I am busy with some other projects, I will do that in the live stream with you guys in the next session. So for now, I'm going to sign off. So thank you so much for your time and your attention. And I'll see you in the